All right, we're recording now.
Oh, crap.
I don't know that it picked up anything you said.
It's all crap.
Except for that, yeah.
I should tell you a story really quick. I know it's been recorded, but it's really funny. We were in the middle of sacrament, and this guy, he's a recent convert, and he is amazing, right?
Mm-hmm.
And he was going to talk in sacrament, but then the lady before him, I think she was nervous. She was really nervous, and she kept saying she was nervous, but she talked for like 25 minutes, like a really long time, a lot longer than normal. Well, then we had a musical number, and then it was time for this guy that we wanted, we're waiting to hear, and he had 2 minutes, and so he stood up and he said, I don't have time to give my talk, but you know who I want to have you guys hear from? Oh, I know what it was. It was a musical number with all the Boy Scouts singing, I hope they come in a mission, and then it goes into these missionaries singing. I think it was like Called to Serve or something, but it might have been a different song. But anyways, it was just really neat, like tears neat, right? Well, anyways, he's like, I want you guys to hear from Elder, I can't remember his name, Elder so-and-so, and I just want, he's just the most amazing missionary, because he's obviously this guy that's been working with him through his whole conversion. And so it just meant so much to him. And so here's this missionary, and he's like, I really want you guys to hear from, I'm just going to say Elder Smith. And you need to hear from him. He has the message, and he's just found out that he's going to be transferring, and this is the last time you guys are going to see him. And I just really would like him to come and bear his testimony. And so he comes up there, and he's this awesome, like always permagrin missionary, just so nice. He goes up in the middle, and he looks at the microphone, he looks at us, and he's like, well, crap. And we're like, what? And so he goes on, I'm like, that's not what we were expecting. He's like, crap. And it's funny to hear this missionary just first word out of his mouth. But then he went on and talked, and it was really cool. It was really, really neat. Now he's gone. But anyways, that's what my meeting with this. Yes, I just felt bad for him. I think after he did it, he was like, oh, oops. But then he went on and played a musical number in every with his companion in every area that he transferred to or went to, and so that was his musical number that day. Was before he left with this other missionary, they sang a duet after the Boy Scouts sang, and it was really neat, really, to see these younger boys singing about missions, and then these actual missionaries singing, and it was really cool. It was really neat.
Awesome.
It was funny. But, okay, I'll focus now. Maybe.
It's cute. Thanks for sharing.
That's a good story. All right, so did anybody have any trouble with part one?
Not very much.
No.
Stephanie, how about you? Did you have a problem with part one?
Not too much, no. It was all right.
All right, you guys are going to jump right into part two?
Yeah.
Okay.
Yep.
All right. Sorry, I can't hear. All right, so number one, confidence interval. In an October 2008 poll, 684 of 1,006 randomly selected college students reported that they had been involved in an automobile accident within the last 5 years. So for A, find the proportion of those surveyed who have been in an automobile accident in the past 5 years. So we're looking for P-hat, right?
Yes.
Which will just be the 684 divided by 1,006.
2006.
Which is 0.6799.
Yep.
All right. Somebody do B, because there's only like 2 questions, so we'll just alternate letters.
Really quick, I noticed on that one, do you need to round to 3 places anymore yet, or do you just not do that?
Typically do. I just didn't.
Okay.
Because it was 9s, and I hate it when 9s round everything off and put it into places. It bothers me.
Down a little bit. Wasn't there one on the test like that?
Yeah.
And I was like, oh no, this must be wrong because I haven't done that before. But so I put, 'cause that's what I got. All right. Okay, I'll do B. Check requirements in constructing a confidence interval for this data. So the requirements are that NP hat has to be greater than or equal to 10, and n times 1 minus p hat has to be greater than or less than 10. So
Equal
the
to.
first one is 1,006, and the second one is like 322. And so both of those are greater than 10. So that would mean that the requirements are met.
Well, the first one's 683 point blah, blah, blah.
Yeah, 9794. Because you multiply 1,006 times 0.68 or 0.6799.
Yeah.
Yeah, but either way, you're correct. I just want to make sure that you knew that you had the right number.
Yes.
So you multiply those two together, and that's what you get. And that has to be greater than 10. And then the 1,006 times the 1 minus 0.6799 is also greater than or equal to 10.
Okay.
Boom. Who's next?
Still figuring it. Okay.
I can go.
Okay.
Determine the margin of error for a 95% confidence interval based on these data. So I multiplied 1.96 times the square root of
B.
p hat, or yeah, p, the 0.6799, and just that whole formula divided by 1,006, and I got 0.0288.
Yep, that's what I got.
Yep.
Okay, and then D, construct and interpret the 95% confidence interval for the proportion of those who have been involved in an automobile accident for the last 5 years. So the upper side is 0.7087, and then I didn't calculate the other one. I must have gotten distracted while I was doing that.
511.
0.6511. What everybody got? Okay. Okay.
So for E, how many college students should you survey if you want a 95% confidence interval with a margin of error no more than 0.015? So the formula is N equals the Z star, which is the 1.96, divided by 2 times the margin of error. So which is 2 times 0.015. And then you square the whole thing, which is 4268.44, so you round it up to 4269.
Yep.
Yep.
Be quiet. You good?
Yep, I'm good.
Okay. I hadn't heard you for a little bit. Maybe I just didn't notice.
I was frozen. Now I'm.
Okay.
Sorry. No, but I'm good.
All right. So number 2, hypothesis test.
All right. Now you're interested in testing a claim that over 60% of all students have been in a car accident within the last 5 years. Use the same information as above and use a level of significance of 0.05. Okay, A, state the null and alternative hypothesis. So the null is saying that, that 0.60, so it'd be 0.60 it's equal to that, but the null, so alternative hypothesis would be 0.60, would be greater than 0.60 because you think it's more accidents.
Yes.
Yeah.
That kind of came out in a big blow, but do you guys get what I was saying?
Yes.
Mhm.
Oh, yeah.
Okay, so compute the test statistic. So it would be Z equals 0.6799 minus 0.60 all, and then over the square root of 0.60 times 1 minus 0.60 over 1066. So I got a final answer of 5.173.
That's what I got.
Me too.
Okay.
For C, determine the p-value based on the test statistic. Sketch your p-value on a normal distribution curve with the test statistic labeled. So I got 1.152 times 10 to the negative 7.
I just put almost 0.
Yeah.
I'm like, that's pretty easy. I'm just going to put almost 0.
Yeah, it was crazy.
So,
Way out there. Yeah.
and that's just the right side of the curve. And it's, well, we already knew it was going to be almost 0 because the z-score of 5 is pretty well out there.
Extreme.
So for D, you reject the null because almost 0 is obviously less than 0.05.
Okay.
Go for E. Who wants to do E?
I can do it. So we have sufficient evidence to suggest that the true proportion of students that have been in a car accident in the last 5 years is greater than 0.60 or 60%.
Yep.
Yep.
Going. This one's going super fast.
Brianna, what's that saying again about the null? Reject the null?
If the P is low, reject the null.
That's right.
Whew.
Okay, we ready to start the quiz?
Yep.
Yes.
So should we go in order? Patty, Stephanie, me, Brianna?
Sure.
Sure.
Okay.
So the symbol for the true population proportion is P. Because the sample
Yes.
is not, so it's P.
Am I after? Patty? Is that my turn?
Yeah.
Mhm.
Okay, so, okay, for questions 4 and 5, suppose that the sample size is 100, P is equal to 0.25, and P hat is equal to 0.10. The requirements for constructing a confidence interval satisfied.
Do the math.
I got yes.
I got 10 and 90.
Yeah, that's what I got. So I got yes also.
You got 10.
Well, because it's the P hat. Isn't it N times the P hat? Or is it N
Oh,
times
I don't.
Yes.
Yeah.
Is it
Yeah.
times P hat? Either way, it's probably going to be.
I think I got. Yeah, I think I was doing it by the P. And either way, I got that it worked. But
Yeah, either way, it'll still be there, but I want to make sure I'm using the right one.
yes, you are. I just checked.
Okay.
Yeah.
Like in my head, it was P hat, but maybe I'm wrong.
Ah. Okay, so the requirements for conducting a hypothesis test are satisfied. Well, they're satisfied, but we don't know if the sample's from a simple random sample. So, but I'm going to say true. Because the confidence interval and the hypothesis testing, the requirement is the same as far as those numbers.
Greater than or equal to 10.
Yeah. The 240 and P hat is greater than or equal to 10, and N times 1 minus P hat is greater than or equal to 10.
That's kind of a trick question because if one of the requirements is it has to be a simple random sample, they don't tell us that. So I mean,
Right.
kind of, oh well.
Does that mean that it's not met because they don't tell us because we don't know?
That's what I mean. I
I
feel like
don't
it's
know,
kind
and that's the part that's tricky.
well, because we don't know if it's met or not. Maybe it has, maybe it hasn't. But we don't know that. So yeah.
I don't remember reading about 2 sets of requirements.
Me either, but simple random sample is a requirement.
For the hypothesis test.
Yeah. And I added it on to the end over here.
I guess we just assume it's a simple random sample.
Yeah, that's the hard part. Let me see if I can find it in the reading, because I got that from the video.
But either one,
Well, in the reading, it just says for the hypothesis testing, it just has to meet those calculation requirements.
Mm-hmm.
okay.
Okay, we're gonna go
We're going to go true.
through.
Yeah.
Yeah.
All right, Patty, you're up.
I'm up again? No,
Yep.
Brianna.
Brianna's up.
Oh, sorry.
Okay.
That's okay.
So a study of first-degree murder trials was conducted in another state. A random sample of 60 people on trial for a first-degree murder was taken, and of these, 45 of the defendants were found guilty. Use information for questions 6 through 8. So find p-hat, the true estimate of the proportion of first-degree murder defendants who were found guilty in the state. So that'd be 45 of 60.
Mm-hmm.
Which is 0.75.
Yeah. That's what I got also.
Create a 95% confidence interval for the true proportion. I'm going to plug this stuff into this handy dandy little thing here.
Oh, see, I'm gonna be slow because I didn't do that. Okay.
Well, we've got the cool deal, so I say let's do it.
Yeah.
See if we get the same thing, and then we'll test it. So 95% confidence interval. So 45 is X, and N is 60, and 95% confidence interval gives a 0.064 to 0.860.
Wait,
So
so 45 is the top number, right? And then the sample size is sample 60 people. So you do 45 on the top, right? And then N is your sample size, put 60 there, and then leave confidence interval at 95.
Uh-huh.
And then what are we looking for? Do you do less than or
Oh, I forgot that part.
you just do not equal to? What are they asking us? Oh wait, for true proportion of first-degree murder trials in the state, there was a verdict of guilty. So how do you know what to put there?
It's the same. That just changes the p-value. It doesn't change.
Oh.
Let's do it longhand anyway, just to make sure.
So I have a question about the little handy-dandy Excel thing.
Yeah.
Are you accessing that through your VMware?
No, it's just Excel software.
You weren't on yet. So if you go to your chapter, like in the individual preparation, click on the chapter and click on any SPSS thing to open it, and it's just instead of opening up all the data for all the different data sets at the bottom, what does it say, Patty?
In
It's like
addition.
a link.
The
Yeah.
simple, what's the thing called? Oh, I gotta open it. It's called the categorical data analysis.
Mhm.
It's an Excel worksheet. You click on that and download it, and you can use it without the remote, unless you don't have Excel on your computer.
Oh, gotcha.
You have
Okay,
Excel?
Thanks. I do. For some reason, when I tried pulling it up last night, like I was doing something wrong or something because it wasn't working, but now it's working. So
Okay.
thanks.
I just kept thinking something was wrong because I thought I'd have to go into the SPS data set and then find that link. So I wasn't reading that thoroughly. So.
Yeah, because I don't know how to do it by hand anyway, because we don't have a P.
How come my numbers? I must be doing something wrong.
Don't you do it with the P hat?
I know, yeah. Wait, hold on.
For
Oh,
the
there's.
CQD.
You do.
Oh, no,
I
I
was
think.
just looking at the standard deviation for some reason.
Yeah, I was trying to do this with something else. And I'm like, why is this not working?
Oh.
This is not making sense.
Aw.
Okay, so I'm going to do this longhand just to make sure.
Ooh, it worked.
So,
So did you guys, oh, so the high side is 0.8679, wait, 0.8595.
Which rounds off to 8.6 or 0.86.
Okay, and then the low side,
I got the low
0.640. Okay.
So yes, it's accurate.
All right.
It's a new thing. We got to double check it, make sure it's right.
I don't know. You guys might, that's pretty handy. I kind of like it.
I know. I'm like, look at all the work I didn't have to do.
I know. We need this for every
I
single.
was worried.
Whoever made this, make another one, please.
Here, so it's 0.64 and 0.86.
Yeah, the second one. That's what I put.
All right. So I think Stephanie, I think you're up.
Okay. If you increase the sample size from 60 to 80, what do you expect to happen to the width of the confidence interval? And I wrote that down. Hold on a minute. If you increase the sample size, then the interval decreases.
That's what I bet.
Yep. To conduct a hypothesis test for one proportion, two requirements must be met. Suppose P is equal to 1/2. What is the smallest N can be, and both requirements still met?
How do you guys do this one? I don't know.
Do I do the well, no. I was going to say, do I do the...
You're trying to figure out the small thing. It seems like there'd be an alteration to the formula you already have, but I don't know. I don't remember learning that or hearing that.
I think it's like the n equals the z-score divided by m, and then that all squared, and then...
But we don't have a z-score. They didn't...
We don't have a z-score. We don't have a confidence interval. We're going to have to use...
So I'm wondering, instead of figuring, if it's greater than or less than 10, we're going to figure for n.
Oh, point. Wait.
Yeah, that's what I'm thinking is you plug in the half for the p hat.
Oh.
So as long as we can get it equal to 10. So we're going to put n times p times 1/2. 0.5 is equal to 10.
And have to be 20.
So then our n would be 20.
Smart.
Right?
Yeah.
Okay, and then what if we put it into the other formula? N 1 minus 0.5 is equal to 10.
Yeah, half of 20 is
So
10.
that's like the same thing.
Okay.
Yeah.
Yeah.
Okay. All right, 20.
Good thinking.
So for this one, it'd have to be 100. Because if that's basically what it is, you're going to divide it by 10.
Yes.
So it'd have to be 100.
Yes.
That makes sense.
You follow, Stephanie?
Yeah, I see what you guys did there.
You got that? I'm not sure what's going on. Look on your face.
Well, my kids are home right now, so I'm actually like, I tell the kid, you parent more with your ears than your eyes, I swear. So I'm listening to what's going on anyway. So.
No worries. I just want to make sure you had that confused look.
Well, I was thinking because it has P, like the require. I was a little confused too, but the requirements, it's n times p hat is greater than or equal to 10, but so. I'm getting there. Hold on. 25 times 20, half of that. Yeah, and then 100 times 10. Yep. I get it. But p hat, this is where I'm kind of confused, because if p hat is your sample proportion, but p is your population proportion, does that make a difference though? Like, because that's the only thing they gave us. The only requirements was with, because if a p hat is a part of that proportion, then anything in that proportion can be not that exact number, and so that's why I was kind of going, well, isn't there a distinction or differentiation between those for this? Does that make sense at all? I know I'm probably overthinking it, but
well, it tells us p hat estimates the proportion. It estimates the p. So if we don't have the p hat, we're using the p anyway, because that's what p hat estimates.
Okay.
And that's what I would go off too, because now the next one here, we have to say same thing, figure out if the hypothesis test, and all they've given us is p.
So there's no other way to format it, because we don't have any information.
In our notes, like in the video, it did say p hat estimates p, the population proportion. So if we have p hat or p, the p hat estimates that. So it can. Okay, am I up? I don't remember. I'm after Patty. Did you? What's funny? What happened?
Oh, my daughter just texted my husband and I and says, I may or may not have just failed a math test. Just so you know that I tried my best. Oh, great. Sorry, I don't even know who went last. Was it me?
I went last, and then.
So I think it's my turn.
I think we did 10 because it was the same as 9.
Yeah.
So we just did them together. Sorry.
You're good. So for questions 11 through 16, use the following information. For the water quality study in the reading, about 60% of the macro invertebrate water quality indicators have historically been associated with good health. The researchers suspect that water quality for the area has decreased. They conduct a hypothesis test using significance level alpha equals 0.05 with the following hypothesis. So then they collect new data, and this time n equals 80 and x equals 38 indicate good health. So the conditions of conducting a hypothesis are satisfied, so I started to plug in those two equations. And for the first one, I got 48, so yes. And then for the next one, I got 32, so yes.
Okay.
Yeah, I got yes.
No, I got yes.
Is it my turn?
Yeah.
Okay. So p hat rounded to 3 decimal places according to this handy dandy thing. Did we lose Stephanie? Hey, Stephanie. We lost her.
Dang.
Well,
She might be popping up.
well, I got for the p hat, it's 0.475 on this.
That's what I got.
That's what I got.
A hand.
Yep.
So for the Z-score, the negative 2.282.
I can't remember. I get confused which one's the P hat and which one's the P.
The P hat is your sample, and your P is your proportion. It's the one that's given. It's the proportion.
Sorry, I mean, which
So
one?
null is your P.
Okay, so we'll be using 0.475, and then the 0.6 is the one that we use every other time.
Well, I think it depends on what we're doing. 0.6 is the null, and it's the one we use for some basic things. But once we start figuring things, you have to figure out P hat based on your sample. That's when you're using your N and your X. That's to solve your when you're doing the test. Hold on. Hi, what's going on? You can't get back on? Huh. Okay, let me re-email you. Well, I just resent you. See if this new one will get you in. Because it keeps saying Stephanie's, that you joined the call, and then it's just your picture, and then it's there, and then it disappears. Right now, you're just a picture. Yeah, I'll just do that. Okay, Stephanie's joining us on speakerphone for the rest because she can't seem to get back on.
Okay.
Can you hear okay, Steph?
Yes.
Okay.
Why put you guys on speakerphone 2 seconds on that one now? Well,
Okay. Well, we use the Excel file to do some of these next questions. So for
did you guys finish 11?
11, we said is true. We plugged it in.
Okay.
So wait, actually, to do that, you have to find the P hat, and then you can solve for it.
Number 11? Okay.
So the P hat was 0.475.
Okay.
And then
Times it times the, wait, where's the sample size, which is, okay. I can just do some math here. Keep going.
okay, we use the Excel file to do it. So it's X is 38, N is 80, the confidence interval is 0.95, and the null hypothesis is 0.6, and the type of test is less than. Once you plug all that in, 12, 13, and 14, well, 11, 12, 13, and 14 are all listed. You get all the information you need on those. Where are you guys at?
No hypothesis again? Oh, 0.60.
0.60, yeah.
And the confidence interval, what are they saying here?
0.95. It's a 0.05 level of significance, which means that the confidence interval is 95.
Okay. All right. I'm up to you.
Okay, all caught up. What are you guys on?
So P hat, would that be 0.475?
Yes. Is that what you guys have?
Yes, for the P hat, 0.475. And I'm trying to figure out by hand, because I still haven't opened the Excel, the Z-score,
All right, so Z,
which I got negative 2.28217.
which is what they have on the Excel. So it's negative 2.282.
Yep.
Yeah, sure. Just 3 decimals.
Yeah, so negative 2.282. So
Okay. So then the p-value, we've got to put it in our probability.
0.011.
0.0112.
That's what I got.
Yeah, 0.11. 0.
Oh, okay. Oh, we're only rounding to 3. Okay. Sorry.
No worries.
Okay.
Then you divide it by point 022, but you divide it in half because they only want to know if it's decreased, right?
Yeah. Why do you have? Well, because we're using the applet. Are you using the applet or the Excel file?
Excel file.
Okay, on the Excel file, go to that where it says type of test. Click on the arrows and click on less than, and it'll already have it. Already has it for you.
Smart.
Okay. I just had it not equal to. Okay.
So that's already done. Okay. 15. Who's up? I don't even know. I've lost track.
I can go. I said reject the null.
Yep. So for 6,
but it's less than.
it's less than 0.5.
Oh, right. Okay.
0.05, I mean.
Okay. Yes. So, which of the following best summarizes the conclusion for this test? I forgot what our null was. Less than 60. Okay. There is sufficient evidence to conclude that the water quality in the area has decreased.
I have this. Oh, that's fine. It says, there is sufficient evidence to conclude that the water quality in the area has decreased.
Yep.
Yeah,
Right.
that's what I said.
So
Yep.
we with all of our answers.
Yeah.
So,
Go back through them. So for 3,
Okay.
we have C. For 4, we have true. For 5, we have true. For 6, we have 0.75. For 7, it's the second one, 0.64 and 0.86.
Mm-hmm.
For 8, we have decrease. For 9, we have 20. For 10, we have 100. For 11, we have true. For 12, we have 0.475. For 13, we have negative 2.282. For 14, we have 0.011. For 15, we have reject the null. And for 16, we have there is sufficient evidence to conclude that water quality in the area has decreased.
Yeah.
All right.
100.
Yay.
Yay. All right, sweet.
All right, are we meeting at Friday, 9:30 again?
Let me double check. I think I'm good to do that. You guys good for Friday at 9:30?
I'm fine for Friday at 9:30. Oh, where I put my calendar. Okay. Friday, 9:30.
Did you say yes on that, Brianna?
Hmm?
Did you say yes? That's cool for you too?
Yep.
Okay. All right, Friday at 9:30 it is.
What was one of your choirs today?
It's choir concert tonight. Actually, tonight is the middle school, but they do it at the high school, and I'm the committee chair for the decorations committee.
Yeah.
I basically show up at the board meetings and then I go decorate for concerts. It's not hard. It just sounds important.
It's hard. Yeah.
But